Okay, so maximum height of our binary tree, right? So guys, in this question we are given with a root node of a tree and we need to figure out what is the maximum depth of our binary tree, right? So in this case as we can see that the depth is 3. Why 3? The one level is 3, one level is this, second level is this, and third level is this, right? So the maximum depth in this case, in this test case, is 3. Fine. Now the thing is how we can solve this problem. So using recursion we can solve this problem very efficiently, right? So what we will do, actually this technique is used in maximum question of tree questions, right? So okay, so we will consider this as a root node, right? Since it is our root node, and what we will do, we will find 1 plus max of height of left subtree and height of right subtree, and we will do this for all the nodes of this binary tree, right? So why we are writing 1 here, right? See guys, if this node is a not null node, then the height of our tree must be at least 1, right? Must be at least 1. Therefore what we will do, we will assume that minimum height should be 1, right? And what else we need to calculate is, we need to calculate what is the length of left subtree and what is the length of right subtree, and after calculating the height of or the depth of left subtree and the depth of right subtree, what we will do, we will find the maximum between them, right? After finding maximum between them, we will add it by 1, and this is nothing guys, this is nothing but our height of binary tree. So we will do this operation for all the nodes of our binary tree, right? So now we'll come to the left subtree, right? So left subtree is here, so we will do the same operation. Since it is non null node, so what we will do, we will find 1 plus max of left and right. So what is left and what is right? This is its left subtree and this is its right subtree. So in this case it is null and this is also null, right? So if we find any null node, so what we will do, we will return 0, right? So from here we are returning 0. So the value of left, the height of left subtree here in this case is 0 and right subtree is 0. So maximum among between 0 and 0 is 0 and 1 plus 0 is nothing, 1, right? So we will return 1 from this node. So we will return 1 here. Cool. Now we will come to the right subtree of our tree, of this node, right? Of this node. So we will come to this node, right? We will come to this node and we will again check, since it is a not null node, so what we will do, we will write 1 and find depth of its left and right subtree. So left and right subtree of node number 20 is this one. This is its left subtree and this is its right subtree. Fine. So we will come to first its left subtree. So left subtree is again not null, so what we will do, we will write 1 plus max of left and right, right? 1 plus max of left and right. So its left is null and its right is also null, so it will return 0 from here. It will again return 0. So value of L and R, or the height or the depth of left subtree and right subtree, again becomes 0. So 0, maximum between 0 and 0 is 0 and 1 plus 0 is again 1. So node number 15 will return 1. Similarly node number 7 will return 1, right? Okay, fine. So now for node number 20, this node, the value of left subtree is 1 and the value of right subtree is 1. So maximum between 1 and 1 is nothing, 1, and 1 plus 1 is 2. So node number 2 will return 2, right? Node number 2 will return 2. Cool. Now we will come to our root node, that is root number 3. So the value of left is the value of left subtree, the value of left subtree, yes, the depth of left subtree is 1 because it is returning 1, and value or the depth of right subtree, that is this one, is what, 2, because this is returning 2. So the maximum between 1 and 2 is of course 2, so 1 plus 2, that is this one, and maximum between 1 and 2 is 2, so 1 plus 2 is nothing, 3. So 3 is, guys, our final answer. 3 is our final answer. Why? This can be considered as the depth, or this can also be considered as a depth. In both the cases, the depth is, or the maximum depth of our binary tree will be 3. So this is our final answer, and this is how we can solve this problem very efficiently, right? Now let me also share the code of this problem. So code is here, right? Fine. So this is very simple code. So see, guys, this is our given root, right? Given node. So whenever we got a null pointer, we will return 0, as I have showed you in algorithm part. And what we will do, we will do this recursive operation for all the nodes, right? We will do this recursive operation for all the nodes. Now what is left and what is right? Left and right is nothing but the maximum depth of left subtree and the maximum depth of right subtree, right? So we will add 1 plus maximum between the depth of left subtree and the and the depth of right subtree, right? So as you guys can see here, we are doing two things. See, if the node is null, then we are returning 0, but if node is not null, then we are adding 1 and finding the depth of left subtree, maximum between the left subtree and the right subtree, right? So these two things we are doing, and after doing these two things, we will finally find the maximum depth of our binary tree. So that is how we can solve this problem. Thank you so much for watching, guys.